AQA, A-level physics, conservation of energy. This is the last of the mechanics videos. Yeah, it got to the end. This is the bit of the specification we're going to be doing, although quite a lot of this I've already mentioned in other videos. Now, the principle of conservation of energy. Energy cannot be created or destroyed. It can only be transferred into other forms. Now, in particle physics, we'll look at the relationship between energy and mass, but in terms of mechanics, the total amount of energy is constant. So a very, very simple GCSE kind of question. A man of mass 80 kilograms falls 5 meters. What energy transfer takes place as he falls? Calculate his velocity when he hits the ground. So ignoring air resistance, what energy transfer? That means what kind of energy do we start with? What kind of energy do we end up with? Have a go yourself. The answer in 3, 2, 1. Okay, so gravitational potential energy goes to kinetic energy, and we have these equations we know very well. mg delta h. It's the difference in height that we're interested in. So mg delta h goes to a half mv squared. Notice that the masses cancel. So if it was a big heavy bloke or a little bloke, they would have the same velocity. They would fall together. And you should get 9.9 meters per second. The rest of this video, we're going to look at a few examples of where you might use an energy equation. In this particular example, we can't use suvat because the acceleration isn't constant. You've got this roller coaster. It has some kinetic energy to start with. It's got more kinetic energy at the bottom. We need to work out the average friction force that acts on it as it descends. And I'll give you a clue how to do it. You use an energy equation. Figure out what types of energy are involved. So I will show you my answer in 3, 2, 1, and there you go. So GPE goes to KE plus work against friction. Notice work against friction, I'm treating it like a form of energy. It's measured in joules. So mgh goes to a half mv squared minus a half mv squared. That's the difference in kinetic energy, plus force times distance. Bung in the numbers, work out F, 1,548 newtons. Here's another one. Motorways often have gravel escape lanes for large vehicles that may get into trouble and need to stop. This lane is on a uniform upward slope, so that's going to help the lorry to slow down. Rises 5 meters in over 100 meters, in 100 meters, let's say. A lorry of mass 1,600 kilograms enters this lane, traveling at 30 meters per second, slows down to a stop in 80 meters. Again, calculate the average frictional force as it slows down. Have a go yourself. The answer is 3, 2, 1. Okay, so the change in kinetic energy is equal to the change in GPE plus work against friction. And if we bung in the numbers, be careful here because delta H is 4 meters, isn't it? If it's 5 meters in 100, then it's 4 meters in 80. So 8,220 newtons. And one more, okay? Read it yourself, have a go yourself, and I'll show you the answer in 3, 2, 1. And there you go.